name is Muhammad Tariza, and I'm going to talk about the introduction. Firstly, clean and safe water is essential for human health, hygiene, and daily activities. Many communities still struggle to access clean and safe water because available filtration systems are often expensive or not effective enough. Contaminated water may contain dirt, chemical, and harmful microorganisms that can cause health problems. So, our group is making a water bottle-based filter because it is ideal for educational and experimental purpose. For me, I choose the design and selected material such as zeolite and fine sand because it clearly shows the layers of physical, chemical, and biological filtration. This will help in understanding how each layer works to remove dirt, chemical, and microorganisms from contaminated water. My task in this group project was making water filter from used water bottle. That's all from me. I will pass the slide to other group members.
Assalamualaikum. My name is Nur Emilin binti Muhammad Samsudin, and I'll be demonstrating a simple water filtration method. The materials used are water bag, cheesecloth, cotton ball, pine sand, coarse sand, zeolite, gravel, granular activated carbon, and biochar. For testing, we use pond water samples near BAP and Moscow, and also methylene blue. For the method, first, cheesecloth and cotton are placed at the neck of the water bag to act as the first filter layer. Next, we add the layers in order: fine sand, coarse sand, zeolite, granular activated carbon, biochar, and finally gravel. Each materials help remove particles, colors, and impurities from the water. Then, we have to measuring the quality of water. Then, we pour the water into the filter and collect what flows out. After filtering, the water becomes clearer and shows fewer suspended particles. And the color reduces, especially when methylene blue was added. Next, we have to measuring the quality of collected water. And the results show that this layer filtration system is effective in improving water clarity.
Assalamualaikum, my name is Nurul Shafika and I'm going to explain about my part result and discussion. This is the visual inspection of methylene blue pond 1 and pond 2 before and after the filtration. From the table color, we can see the color of methylene blue before its dark blue has changed to clear after the filtration, while pond 1 and pond 2 before the filtration is brownish and after the filtration is clear. From the table particle, we can see methylene blue contain visible dye before the filtration and after the visible dye has become none, while pond 1 and pond 2 contain sediment before the filtration and after the filtration, the sediment has reduced. Next is odor. Methylene blue contain smell of chemical before the filtration and after the filtration, the chemical smell has become weaker, while pond 1 and pond 2 before the filtration has strong earthy smell and after the filtration, the smell has become mild. Next is dissolved oxygen. From the graph, we can see that after the filtration, dissolved oxygen in each sample, methylene blue pond 1 and pond 2 has increased. Same goes to pH. From the graph, we can see that each sample has increasing pH from the original pH after the filtration. Next is total dissolved solid. From the graph, we can see that the total dissolved solid for each sample has increased after the filtration. From the flow rate graph, we can see that each sample has increasing flow rate after the filtration than before the filtration. Lastly is turbidity. From the graph, we can see that after the filtration, each sample has decreasing turbidity than before the filtration. For final comparison and discussion, The table shows the result of before and after the filtration for each type of water sample. Next comparison, the table shows the result of each DIY filter water and mineral water and filter water. And lastly, the discussion. From the first question, which water sample show the greatest improvement? It shows that pond A has shows the greatest improvement. It is because after the filtration using the DIY filter water, the result of turbidity has reduced. The color has changed from brownish to clear. The sediment particle has reduced, and the pH have shifted from acidic to almost neutral. Smell has reduced from strong earthy to mild earthy smell, and the dissolved oxygen in the water from pond 1 has increased. Next question is, how close does your filter water quality come to commercial standard? It is quite close because after the filtration, it shows visually clear and the total dissolved solid and pH is safe. But the turbidity is still higher and the odor is still contain the smart earthy smell. Next question is, what could be improved in your filter design? Firstly, for turbidity reduction, we can enhance the use of fine sand or the cloth layer to capture more suspended particle. And for odor removal, we can increase the layer of activated carbon to fully eliminate the residual smell from the water. That's all from me. Thank you.
Hello everyone, my name is Joanna James and I will do conclusion for our video presentation. In conclusion, our DIY prototype successfully demonstrated the principle of mechanical filtration, moving all raw samples toward acceptable physical standards. Our greatest success was in Pond Water 1 BEP, which showed the greatest improvement. We achieve a clear result by dropping turbidity from 8.81 NTU to 2.11 NTU. The filter also stabilized key chemical indicators. pH was raised significantly from 6.54 to 7.74 and dissolved oxygen increased to 7.50 mg per liter, showing good aeration. While we achieve parity with commercial standards for DO and pH, we fail to match them in purity due to two chemical issues. First, total dissolved solids TDS increased for all samples. Example, pond 2 jumped from 1 to 7 mg per liter, indicating materials leaching. Second, pond 2 turbidity spiked sharply to 20.00 NTU, revealing a critical filter failure or channeling. Therefore, our key focus for improvement must be media stability. We would pre-wash all media to eliminate soluble fines and integrate a commercial grade fine pre-filter membrane to prevent media washout and secure consistently low turbidity. Thank you.